Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the questions in Paper 1 of the 2013 JEE Advanced Physics paper. The order I'll be following will be the same as in Code 0, but in any other order the questions will be the same, just the order will be different, so you can figure that out for yourself. In this paper, question 1 is a particle of mass m being acted on by a force which is k times x I cap plus by x squared plus y squared to the power 3 by 2 plus y j cap by x squared plus y squared to the power 3 by 2, and it is being taken along the Cartesian plane from the point a comma 0 to the point 0 comma a along this circular path. So because of this circular path and because of root x square plus y square in the denominator, I can see that it will be easier to work in polar coordinates. So we'll switch to those. X is equal to r cos theta, y is equal to r sin theta, which means that r is x squared plus y squared to the power 1 by 2, and theta is tan inverse y by x. So if you substitute these two values for x and y in f, you get f is equal to k times r cos theta I cap divided by, now this term is r cube, plus r sin theta by r cube, which is k times k by r square times cos theta I cap plus sin theta j cap. Now we know what this vector is, cos theta I cap plus sin theta j cap. If this angle is theta, this vector is a vector of magnitude 1 in this direction. So it is basically the unit radial vector r cap. So we can write f as k by r squared r cap. So this means the structure of f is such that the magnitude is inversely proportional to the square of the distance from the origin, and the direction is always radially outward. Right. So from this we can see that this force is exactly identical to the force on a particle of charge q, positive charge here, except for the constant k. This will absorb all the other constants. But if we keep a positive charge here and if we keep another positive charge here at the origin and move this charge about, then the force this charge will experience will be of the form of k by r squared r cap. But k in that case will be the original k multiplied by the charge of this multiplied by this charge multiplied by this charge. So that's absorbed into the constant, that doesn't matter. But this force is exactly the same as the force experienced by a positive charge moving in this quadrant by a positive charge kept at the origin. And we know for that the potential energy just depends on the distance between the two. So if the distance between the two is a here and a here, the potential energy is the same in both the cases. So the work done will be 0 and the answer will be D. But if you're not convinced of that, I can just quickly show you the rigorous way of proving that the work done will be 0. All we need to do is find the potential energy at this point, call it capital A, and this point, call it capital B. So the potential energy at capital A will be integral of minus integral of from whatever the reference is to the point R or A f dot dr. Now to calculate the potential A, what I'll do is I'll take this particle along the x-axis from infinity to this point. We know that at infinity the potential is 0, that is what we always assume. So this will mean UA is equal to minus infinity to A k x I cap by, okay, this whole term multiplied by dot dr. But dot dr in this case will simply be dx I cap, because there is no displacement in the y direction. And when you take the dot product, the j term will cancel out. You will just have x dx by x square plus y square to the power 3 by 2. Not only that, but y will be 0. Right. So you'll get x by x squared to the power 3 by 2 or x by x cube. I cap already joins with that and becomes 1, dx, which is minus infinity to a k by x squared dx, which is equal to, this will be x to the power minus 1 by minus 1 or 1 by x, so it will be k by a ultimately. And then you can do the same thing when you come from this direction. Infinity, whether it's infinity in the x or y direction, will give you potential 0, and if you come from infinity to 0 comma in the y direction, you'll see the potential energy is k by a again, right? So the potential energy is the same, that means the work done is 0. The next question, you are given two rectangular blocks having identical dimensions, and one of them has conductivity K and the other 2K, and the temperature difference between the ends is the same. It takes a certain amount of time to transport the first one. How much time does it take to transport the second one? Now in questions like these, a lot of the times people try to do it in their heads very quickly. I certainly did when I was giving my exams, but you tend to make a lot of errors in those. So the best way is to do these systematically, and it doesn't really take a lot of time if you do this properly. So I'm going to do this as systematically as possible. The general equation for us is delta Q by delta T is equal to Ka by L delta theta. And we'll just apply it to both the cases. In the first case, the two rods are in series, so we can see that the resistance will add, right? And it helps to write it in the form of delta theta is equal to delta Q by delta T times L by Ka, because then it becomes like V is equal to I times R. This is like V, this is like I, this is R. So L by Ka plays the role of resistance, and I do that because you can already use the results of resistance in series and parallel, because you've already done them in mathematically similar cases like Ohm's law. So in the first case we have delta theta is equal to delta Q by delta T1. See, the amount of heat is the same in both cases, and the temperature difference across the ends is also the same in both cases. So delta Q and delta theta will be the same in both cases. In the first case it's series, so we'll have the resistance being added up, and the blocks have identical dimensions, so we'll have L by Ka plus L by 2Ka, right, which becomes delta Q by delta T1 times 3L by 2Ka. And in the other case we have delta theta is equal to delta Q by delta T2. Now they're in parallel, so their inverse will add up, and then we'll take the inverse of that. So you'll have Ka by L plus 2Ka by L inverse. So this will be 3Ka by L, so inverse will be L by 3Ka. So delta Q by delta T2 is equal to L by 3Ka. Now you just divide the two. Delta theta will cancel, delta Q will cancel, L by Ka will cancel. So what you're left is the first equation divided by the second equation gives you delta T2 by delta T1 is equal to 9 by 2. And delta T1 we are given is 9 seconds, so that is this is not into, this is into. So the equation will be 1 by 2 will be 1 is equal to delta T2 by delta T1 into 9 by 2, and delta T1 is 9, so this gives us delta T2 is 2 seconds, which means the answer is A. Right. Let's move on to the third question. We are given two non-reactive monoatomic ideal gases, atomic masses in the ratio 2:3. So we'll just take the first atomic mass to be 2m and the other atomic mass to be 3m. We want to find out the ratio of their partial pressures if they are kept in a vessel at constant temperature. No, the ratio of partial pressures is given to us, 4:3. We want to find the ratio of their densities. Right. So if the temperature is the same, then we can use the equation Pm is equal to rho RT. You know how this equation is derived from PV is equal to nRT, right? So Pm is equal to rho RT. So we'll have P1m, or we'll just write 2m in this case. Actually, what it will also help us is taking the pressures to be 4p and 3p, right? So we'll have 4p times 2n, that is 8pm is equal to rho1 RT, and in the second case we have 9pm is equal to rho2 RT. So from this we can easily see rho1 by rho2 is equal to 8 by 9. So the answer is D. You could have taken P1 M1 is equal to rho1 RT, P2 M2 is equal to rho2 RT divided, and you would have gotten the answer to be this. And then you could have done M1 by M2 is equal to 2 by 3, and P1 by P2 is equal to 4 by 3 or 8 by 9. So you could have done it in both cases. This turned out to be a quite short question, but generally in lengthy questions it helps to take this approach right from the start, because then you tend to make less errors, because whatever information you were given in the beginning, you've just taken care of that, and then now you don't need to worry about this for the rest of the question. So let's do the fourth question. A particle of mass m is projected from the ground with an initial speed u0, a standard projectile, and at the highest point it makes an inelastic collision with another particle thrown upwards with the same initial speed u0. Okay, so first we have our standard projectile, u at an angle theta, going like this, and then when it is at a highest point, it hits an other particle which was thrown upward with the same initial speed u0. So there was another particle thrown upwards with the speed u0, and by the time it reaches here, this particle is here as well. So they are both here at the same time. So the first thing we need to see is, this starts with the speed u0, but this starts with the speed u0 sine theta in the vertical direction. But they both travel the same distance, this distance, so obviously they started at different times. The initial time, the time at which this was projected, was not the time at which this was thrown up. That's the biggest mistake students might make. They might assume they were both thrown upwards simultaneously, but that's not true. So we can calculate this u0 in terms of the other variables. What is this? This is the maximum height, which is u square sine square theta. In the question they've taken alpha, but I'm used to taking theta, so let me just take that and we'll just replace that at the end. U square sine square theta by 2g. Right, this is this height. So we know, if we want to find out the vertical component of this velocity when it reaches here, v, we know that v square will be u square minus 2gh. Right, that's the beauty of this third equation. This third equation, v square is equal to u square plus 2as, does not have time in it, so you don't need to worry about times. H will be u square sine square theta by 2g. 2g cancels. U square minus u square sine square theta is u square cos square theta, which means that v is equal to u cos theta. Right, it can be minus u cos theta as well. That will mean it's coming down with the same speed, but we are given that it is hit when it is thrown upwards. Right, so at this point this has a speed upwards equal to u cos theta, and this particle has a speed in the horizontal direction is equal to u cos theta. So we don't, and they both have the same mass, so we don't really need to worry about the specifics of the case. Now the question just becomes, one particle going here with the speed u cos theta, the other particle going here with the speed u cos theta, they make an inelastic collision. Obviously everything is symmetric about this axis, so they'll be going in this direction. With what speed is of really no concern to us right now. We know that it has to be in this direction, and this angle is 45 degrees. Right, so the answer will be 45 degrees or pi by 4, which is A. If this was u cos theta and this was, let's say, 3u cos theta or 2u sin theta or something, then we would actually have to calculate and solve the equation. But it turns out that both of them ended up being the same, and from that we can easily say that it's around 45 degrees. There is no reason for it to go anywhere else. Right, the sum of this vector p and this vector p will always be in this direction, and since the mass and the speed are the same, they both have the same momentum. Let's go to question number 5 now. A pulse of light of duration 100 nanoseconds is absorbed by a small object at rest. The power of the pulse is given and the speed of the light is given. We want to find out the final momentum. So this is a pretty straightforward question. We know that E is equal to PC, right? Or you can just get this from P is equal to H by lambda and E is equal to HC by lambda. So P is equal to E by C. The energy will be the power multiplied by the time. So 30 into 10 to the power minus 3 multiplied by the time, 10 into 100 into 10 to the power minus 9 divided by the speed of light, 3 into 10 to the power 8. So first of all, let's take care of the tens. You have 1000 cancels with this, 10 to the power minus 17 and 3 cancels. So you have 1 into 10 to the power minus 17, which means the answer is B. Pretty straightforward standard question. Right. Let's look at the next one. You have a Young's double slit experiment using monochromatic light, and you need the path difference corresponding to points having half the peak intensity. So there is an assumption to make in this question. Unless something else is given, we have to assume that both the slits have the same width, so that the intensity coming from both the slits is the same. That's not expressly given, but without that it doesn't work. So, and that's a reasonable assumption if nothing is given, I think. So in this question, in that case, we have the formula: the net intensity is equal to 4I0 cos squared delta by 2, where delta is the phase difference, right? And we need this to be 2I0 because half the peak intensity is 4I0. That means cos squared delta by 2 is equal to 1 by 2, or cos delta by 2 is equal to plus minus 1 by root 2, which means delta by 2 is equal to n pi plus minus pi by 4, right? But what is delta by 2? We know delta is 2 pi times delta x by lambda. So this divided by 2 means x times pi by lambda, which gives us delta x is equal to this into lambda by pi, so n plus minus 1 by 4 lambda. But this doesn't seem to be any one of the options. So the options are all in terms of 2n. So what we can do is, we can just take n is equal to m by 2. Now this is true for any integer, whether this is odd or even. If n is an integer, then 2n will also be an integer, right? Which is m. So we'll just take m is equal to 2n, and we'll just get, I'm only doing this to match with one of the options, right? So this as an answer is completely acceptable. But n has to be equal to m by 2 for an integer m, right? It doesn't matter whether n is odd. Even if n is 7, 7 is equal to 14 by 2, right? So m will be 14 then. So it will be m by 2 plus minus 1 by 4 lambda, which is 2m plus minus 1 lambda by 4, which gives us B. The next question is a straightforward application of the lens formula. First of all, we are given that the wavelength of light inside the lens is 2/3 of that in free space. So the speed inside the lens is equal to 2 by 3 times the speed inside free space, which means that mu has to be 3 by 2 because mu is inversely proportional to the speed, right? Also, what we are given is aid distance behind the lens is the image, so V is equal to positive 8. I'll just draw the figure for the sake of convenience. We don't know what type of lens it is. It's a plano convex lens, but we are not given exactly which side the plane part is, so I'll just draw a random lens here. That doesn't matter. We know that V is positive 8 because these are the directions of the incident rays, and it is 1/3 the size of the object. So from that we know that m is equal to minus 1 by 3 because it is also real. And we need to find out the radius of the curved surface, right? So whatever it is, we know one surface is flat, one surface is curved. It doesn't matter which one it is. Actually, both of them will give the same focal length. So m is equal to minus 1 by 3, which basically gives us v by u is equal to minus 1 by 3, which gives me u is equal to minus 3v, which is minus 24. Now just straightforward application of the lens formula. 1 by 8 minus 1 by minus 24 is equal to 1 by f. 3 by 24 plus 1 by 24, 4 by 24, which means f comes out to be equal to 6. But what is f equal to? F is equal to mu minus 1, that is 3 by 2 minus 1, times 1 by r1 minus 1 by r2. Now if this is the plane surface and this is the curved one, then we have 1 by 0, because this is the plane, 1 by infinity, because this is the plane surface, minus 1 by a negative number. So we still have 1 by r. If this is curved and this is plane, we have 1 by r minus 1 by infinity. So both of them give the same thing, 1 by r, and this is half. So r by 2, which gives us, 1 by 2r. And this is actually not f, this is equal to 1 by f, right? So which gives me f is equal to 2r, or r is equal to 3, which means the answer is C. In the next one we have copper wire of length 2l and radius 2r welded to a copper wire of length r and radius r, stretched by applying forces at the two ends. So if you are applying forces at the two ends, that means the force everywhere is the same, otherwise the system would not be in equilibrium, right? We want the ratio of the elongation of the thin wire to that of the thick wire. So the Young's modulus is the same for both of them, that is equal to f by a by delta L by L. This is the same for both of them. So we'll get f by a1 will be proportional to 4r squared, it will be pi times 4r squared, into L by delta L. L will be 2L by delta L1, whatever it is. This will be the same as f by pi into r square for the second one, L by delta L2. Pi r square go, L and L go, F and F go. So we get delta L1 by delta L2 is equal to, let's see what's left, is equal to 2. And that's what we're asked. So it's C, right? Quite a straightforward, simple question. The next one, we are given a ray of light is traveling in the direction half I cap plus root 3 j cap, and after it reflects, it travels along the other direction. What is the angle of incidence? Right. So there are two ways to do it. One of them is the quick way, which is just to draw the vectors and try to figure it out, because it's a multiple choice question. So I plus root 3 by 2 is a vector like this, which makes an angle 60 degrees. And I minus root 3 by 2 is a vector like this, which again makes an angle 60 degrees. So if this vector is the first one and this is the second one, I think it's pretty easy to see that this will be the mirror, right, along the x-axis. And if this is the mirror, this is 60, then this will be 30, so the angle of incidence will be 30 degrees, or A. But if you weren't convinced by this, there is actually a rigorous way to solve this as well. Let's say this is the incident direction, this is the reflected direction, and this is the normal, and this is theta. So what is this angle? This is theta, this is theta. This angle is 180 minus 2 theta. But what is this? This is the deviation. So the deviation is 180 minus 2 times the angle of incidence. Right, and we can calculate the deviation between these two. Both of them are unit vectors, so we just take the dot product. That's going to give us the cos of the angle between them. Right, so the dot product will be 1 by 2 into 1 by 2 plus root 3 by 2 into minus root 3 by 2, which will be equal to 1 by 4 plus 3 by 4, or 1. Right, so cos delta will cos of this angle will be 1. So what is this angle? Sorry, my mistake. It won't be 1. It will be minus half. Right. So if this is minus half, that will mean delta is equal to 2 pi by 3 or 120 degrees. Right. Cos 120 is negative of cos 60. Cos 60 is half. Right. So delta is 120, which also gives us I is equal to 30 degrees, which again gives us A. So there are two ways of solving this question. The next question, the next question, we need to figure out what the actual reading is on a vernier caliper. And again, this is a straightforward application of formulas. First of all, let's calculate the standard parameters of the vernier scale. So one main scale division we can see is 5.15 centimeters minus 5.10 centimeters or 0.05 centimeters. One vernier scale division is 2.45 centimeters, which corresponds to 50 division. So this divided by 50 centimeters is one vernier scale. This comes out to be 0.049 exactly. Right, just multiplied by 2, this will be 4.9 by 100. Right. What is the least count? We know the least count of a vernier caliper is one male scale division minus one vernier scale division. So that is equal to 0.001. Right. And finally, we can just apply the formula to get the answer. The reading is the standard 5.10, which is the main scale reading. The reading is the main scale reading plus number of divisions multiplied by the least count. Right. So 5.1 is the main scale reading plus 24 multiplied by 0.001, which is the least count. So which is equal to 5.124, and the answer is B. Right. Now we move on to the next section, in which one or more of the options will be correct. And just a small tip I'll give you: the best way to solve questions in which one or more options are correct is, so that you don't miss any of the options, is to treat each option as a true or false. So you have to solve basically 4 questions, one for each option, whether it's true or false, because otherwise you sometimes forget some important options which might seem too obvious to you to want spending much time on. Right. So let's start with question 11. There are two parallel plate capacitors. Each of them have a capacitance C, and first switch S1 is pressed to fully charge the capacitor, and then it is released, and S2 is pressed, and then S2 is released, and then S3 is pressed. So I'll just draw the configurations after the things have happened. So initially nothing has happened, then we press switch S1 to fully charge the capacitor C1 and then release it. So after pressing and releasing switch S1, after releasing S1, the state will be, this doesn't matter because it's not connected to anything. Here we'll have a capacitor C1, C2, V0, and this is 2 V0. And after you've pressed and released this has a potential difference of 2 V0. So this is the positive terminal, this is the negative terminal, and the charge is 2C V0. Right, plus 2C1 V0 and minus 2C1 V0. So we press this one. This is the only circuit that was completed. It was completely charged. Then we remove this. Now this is no longer connected, but these two plates are still charged. Then you connect this to C2 and release. Right. So then this is the middle one will be the only circuit that will be operational, because S1 and S3 will be open. Remember, only one of the three is closed at a particular time. Right. Now we close S2 and release S2. So after releasing S2, what will be the situation? So I'll just draw this part, I'll not draw the first part. So this is C1, C2, and then you have this is V0, but you don't know the charges now, right? So now the potential across these two has to be the same. If this is positive, some charges go here, so this will have positive charges on it as well, right? But okay, both of them actually have a capacitance C. They just, the names are different, so we'll just write this as 2CV0. So I won't solve this. You can see directly that this will be plus minus CV0, and this will also be plus minus CV0, because then they both have the same potential difference across them. Right, you can just solve it and try to do this. So take this Q1, this Q2, Q1 plus Q2 will be 2CV0, and Q1 by C will be Q2 by C, which means they'll be equal, where I just did it. Right, so this is after releasing S2, and then you press S3, right? So after releasing S2, you press S3, then only the third circuit is complete, and what you'll finally have is this is V0. Now this is the positive, this is the negative terminal. So now it will be positive and negative CV0. So this had 2CV0, now this has CV0 and gives CV0 to this, but then it completely inverts, right? Twice the charge flows through the battery and this completely inverts. So after some time, charge on upper plate of C1 should be CV0. So first statement is false. Charge of upper plate on C1 is CV0, so second statement is true, so B is an option. The charge on the upper plate of C2 is not 0, so C is false. The charge on the upper plate of C2 is indeed minus CV0. So B and D are the two options that are correct. Right. So this is how you do it. You take each option and you check it as a true or false. Right. Let's move on to the 12th question. A particle of mass m is moving with a constant velocity 4i meters per second, enters magnetic field. It goes from x is equal to 0 to x is equal to L, and it emerges with this second speed. Okay, so this is the xy plane for us. This is x is equal to 0, this is x is equal to L. The magnetic field exists in all y directions between this region. Right, we don't know the magnitude or the direction of the magnetic field. Initially, U1 is 4i cap. So it's going like this. 4i cap. By the time it comes out from the other side, its velocity is 2 times root 3i plus root 3j, or we can write it as U1 is 4i cap, U2 we can write it as 4 times root 3i by 2 plus j by 2. And this is the unit vector where cos theta is root 3 by 2, so theta is 30 degrees. So it comes out in this direction at 30 degrees. So we'll not draw it here, it will be a little bit higher up if it starts near the x-axis. So let's say here. So this is 4 in the x direction, this is 30 degrees, this is also 4. Right. So first of all, both these vectors span the xy plane, right? So the movement has been in the xy plane, so the magnetic field has to be in the z direction. Whether it's in the positive or the negative z direction depends on what direction the acceleration was. For this, the force was in the upward direction, and you can see from the right hand rule that the force will in the upward direction, this is x and y, if the magnetic field is going into the plane but the positive z is coming out of the plane. Right, V cross B, if B is going into the plane, will give upwards, but the positive Z is coming out of the plane, so the magnetic field is in the minus Z direction, so A option is correct. Then we need to calculate the magnitude. Right, so let's say this was the center of the circle about which this was going. Right, so this is R, and this is also R. Right, now because this is 90 degrees, this is 30 degrees, means this is 30 degrees. Right, we are just trying to calculate the value of R at this point. Right, so many ways to calculate R. One of the easier ones is we know that this time took 10 milliseconds. 10 milliseconds is 10 into 10 to the power 3 seconds. 10 to the power minus 3 seconds. This is the time it took, and we know the speed is 4 throughout, right? The speed initially and the speed finally are the same, which is 4. So the time it took would actually be 30 degrees by 360 degrees into 2 pi r. This would be the distance traveled divided by the speed. This would be the time, right? The distance traveled like this in a circle will be 30 by 360 times 2 pi r, and divide that by the speed will give you the time. This is 10 into 10 to the power minus 3. Right, 30 by 360 we can write as 1 by 12. Right. So what we get from that is, this is 6, this is 1 by 100. So we get r is equal to 24 by 100 pi. But we know this is equal to mv by qb. Right. M into v, v is 4 by q times b. So from that we can directly get v. 4 cancel with this gives us 8. This gives us 6. And 100 pi by 6 will be 50 pi by 3. So this means magnetic field is 50 pi by 3 m by q, which means the answer is C. So A and C would be the correct answers. Let's go to question 13. So in question 13 we have a horizontal stretch string vibrating in the fifth harmonic, and we are given the equation. So first, the best thing would be to write the equation in terms of pi, because pi is given to be 3.14. So y of x comma t comes out to be 0.01 sine of 62.8 times s. 62.8 seems to be 20 pi, right? So it's sine of 20 pi cos of 200 pi t, right? And from this we can directly see that the wavelength lambda is 1 by 10 and the time period is 1 by 100, because after time period 1 by 100 it becomes 2 pi, and after 10 this is x. After lambda 1 by 10 this becomes 2 pi and it repeats itself. So lambda is 1 by 10 and the time period is 1 by 100. Now if it's vibrating in the fifth harmonic, that means we know the structure it will have, right? It will have 5 loops. 1, 2, 3, 4, 5. This is not a traveling wave, by the way, this is a standing wave, right? So this is sort of what it will be. At one extreme it will be like this, the other extreme it will be the opposite of that, right? So from this directly we can see that the number of nodes is actually 4, it's not 5, right? And lambda is 1 by 10, which is 0.1, and lambda is this thing, right? It's 2 loops makes a lambda. So if this is 0.1, this whole thing is 0.25. So the first statement is false, but the second statement is true, so B is true. The maximum displacement of the midpoint of the string is, so the midpoint is an antinode, so the maximum displacement certainly is 0.01. So C is also true. And the fundamental frequency is 100 Hz. So no. If it's vibrating, this means the frequency is 100 Hz. But 100 Hz is for its fifth harmonic, right? And we know the frequency is proportional to the harmonic when it's tied at both ends, right? Frequency is actually equal to NV by 2L. These are the standard formulas you need to remember, right? So it's proportional to N. So the fundamental frequency is not 100, the fundamental frequency is 20 Hz. If this was vibrating in the fundamental mode, then the frequency would be the fundamental one, right? But the fundamental is 20, it's vibrating in the fifth harmonic, therefore it's vibrating at 5 times the frequency. So the answer will be B and C. Let's move on to the next one. A sphere of radius r and density rho is attached to one end of a massless spring. The other end is connected to another solid sphere. The complete arrangement is placed on a liquid. So the liquid has a density 2 rho, one of them has rho and the other has 3 rho, right? So first of all we'll assume they're submerged, and if they sink that means they will be submerged. If they don't sink, then we'll assume that they'll partially submerged, and to find out how much they float with. So this is 2 rho, this is rho, this is 3 rho. Obviously 3 rho will be going down, and rho will be going up, and the spring has a force constant K, right? And so just let's try to write down the equations, the simple equations. For the second one, we'll have 3 rho times V times G, that is mg downwards, right? Minus mg will be downwards on all of them, kx will be in this direction and in this direction if we assume elongation, and b will be upwards for both of them, right? So this minus kx minus the buoyant force. The buoyant force will be 2 rho Vg, right? This is equal to 0 because they are in equilibrium, which means kx is equal to rho Vg. Now for the upper one, we'll have a magnetic field of rho Vg downwards plus kx downwards and minus 2 rho Vg buoyant force, right? And kg is rho Vg, so this is exactly equal to 0. The fact that it is exactly equal to 0 means that the light sphere is completely submerged, right? And what is the elongation? X will be rho Vg by k, which is rho into 4 by 3 pi r square g by k, or 4 pi r cube rho g by 3k. Hang on, I'm missing an r somewhere. I'm missing a fact. Yeah, this is 4 by 3 pi r cube, obviously. So r cube. So the answer will be B and D. Now notice what would have happened if this was not 0. Then this buoyant force would be the term that would have changed. It would have actually been less because then a portion of the sphere would have been submerged. This buoyant force assumes that the sphere is completely submerged. And when it's completely submerged, it was allowed to reach equilibrium, therefore it is completely submerged. If this equation did not turn out to be 0, if kx turned out to be something different, then this buoyant force would change, which means the volume submerged would change. That's what the question was trying to test us on. Let's move on to the next one, question 15. Two non-conducting solid spheres have volume, charge, densities ρ1 and ρ2, and they touch each other. So this is R and this is 2R, and they have ρ1 and ρ2. The net electric field at a distance 2r from the center is 0. Net electric field at 2r from the center is 0. So this is the center of the smaller sphere. The net electric field at a distance 2r from it, along the line joining the center, that means along this line. But still there's some ambiguity. If it wasn't along this line, there could have been a million directions, any point radially 2r from here. But if it's along this direction, still there could be two possible places. This could be here, which is the distance 2r from this point, this being r, 2r. Or it could be here, a distance 2r within the sphere, right? And you can see that out of the 4 options, 2 are positive, 2 are negative. So you can tell that if both of them were if both of them had different magnitudes, one was ρ1, the other was, one was positive, the other was negative, here it might be 0, but if it's inside, then they both have to have the same charge for it to be 0, same sign, same positive or negative value, right? So we'll do both the cases separately. When it's outside where the field is 0, that's easy enough. Both of them will behave like point charges placed at the center. So ρ1 into 4 by 3 pi r cube by 4r squared is equal to ρ2 into 4 by 3 pi into 8r cube by, this distance is 2r. What is the distance from this center? This is 2r and another 2r and another 5r. So 25r squared. Right. So 4 by 3 pi cancels, r cube cancels, which means ρ1 by ρ2 is equal to r and r cancel, 32 by 25. But they have to be opposite signs, because this will have a field in this direction and this has to have the field in the opposite direction. That is the other thing the questioner is trying to test us on. What is the sign? If the electric field here is 0, both of them have to have opposite signs, which means ρ1 by ρ2 will have to be minus 32 by 25. So this gives us option B. What about the other one? In this case, the field due to the first one will be rho 1 into 4 by 3 pi r cube by 4r square, the same. With the second one, the field due to this inside sphere will be the only thing that will count. This field due to the outside sphere will be 0. So it will be rho 2 into 4 by 3 pi r cube, not 2r cube now, by r square, which gives me rho 1 by rho 2 is equal to 4. So the answer is B and D. Take care of the signs. This is a question in which the signs are very important. Right. Let's move on to the next one, the 16th problem. A bob of mass M suspended by a string of length L1. Given minimum velocity required to complete a full circle. If this is a string, then the minimum velocity required will be v is equal to root 5 gl, not root 4 gl. That is a concept I hope all of you are familiar with. If it's a rod, it's root 4 gl. If it's a string, then the tension becomes 0 before the acceleration becomes 0, and that needs to be taken care of as well, and v becomes root 5 gl. When it is at a highest point, let's say here, after moving, it collides elastically with another bob suspended by a string of length L2, which is initially at rest. So there's another bob here in a string of length L2 initially at rest. After the second bob, after the collision, the second bob acquires the minimum speed to complete the circle. So the speed here of the second bob is equal to root 5g L2. This is L1. Right. And what is the speed of this one by the time it reaches here? It is root GL1. Right. And we are given that is the mass of both of them the same? Both of them have the mass m. So we know that if both of them have the same mass and it's an elastic collision, then there's a simple result which you should remember, that the speeds are interchanged. You can actually derive that, but it's good to remember. So the speeds are interchanged. So if this has a velocity root gl and this is at rest, and by the time it's over, this will be at rest and this will have a velocity root 5gl2. Right? And by momentum conservation, they both have the same momentum, which gives us m root gl1 is equal to m times root 5g L2, which just gives me L1 by L2 is equal to 5. These are single digit answer questions, so the answer to this one will be 5. Let's go to the 17th one. A particle of mass 0.2 kg moving in one dimension under a force that delivers a constant power of 0.5 watt. Initial speed is 0. What is its final speed after 5 seconds? So this is a pretty simple question. A 0.5 watt is the power for 5 seconds. That means the total work done is equal to 0.5 into 5. That is equal to 2.5 joules. Right. This is equal to the change in kinetic energy. Initial speed is 0. This is equal to half into 1 by 5 into t squared into v squared, which gives me directly v is equal to 5 meters per second. So this was a pretty straightforward, one of the easier questions in this paper, I think. The next one, work functions of silver and sodium are given. Ratio of slope of stopping potential versus frequency plot. So what is the equation? The kinetic energy is equal to h mu minus phi. This is the kinetic energy maximum. And the stopping potential is such that EV0 is equal to the kinetic energy maximum. That's where you don't see any electrons when you apply a reverse potential of V0, which means V0 is K max by E. So V0 is equal to h by E times mu minus phi by E. So we saw that the ratio in both of those cases will be h by E, only the intercept will be different. Y is equal to mx plus c. If we plot the frequency versus the stopping potential, the ratio of the slope of both of them will be the same because both of them will have the slope h by E. So the answer will be 1 for the 18th one. Right. Let's go to the 19th one. The half-life is given to us to be 1386 seconds and the activity is 10 to the power 3. The activity is defined as dn by dt. So if n is equal to n naught e to the power minus lambda t, then dn by dt, or the activity, is equal to minus lambda n, because it is equal to minus lambda n naught e to the power minus lambda t. Right, still proportional to n. So the half-life is 1386 seconds. We already know standard formula for half-life. So lambda is equal to ln2 divided by t half, which means that lambda comes out to be 0.693 by 1386. You'll see this is twice of this, so it will be 1 by 2000. So lambda we already get, it is 1 by 2000. The fraction of initial nuclei that will decay in the first 80 seconds. Right, so we need the fraction of nuclei that will decay in the first 80 seconds. So we can actually get n naught directly here as well. We are given minus lambda n naught, which is the activity, is equal to 10 to the power 3, which means that n naught, the mod of this is obviously 10 to the power 3, which means that n naught is 2 into 10 to the power 6. Right. Now after 80 seconds, we'll have n is equal to n naught e to the power minus 80 by 2000. Right. 8 by 200, which is 1 by 25. So n by n naught is equal to e to the power minus 1 by 25. This is the fraction that are left. So the fraction that are disintegrated will be 1 minus n by n naught. That will be 1 minus e to the power minus 1 by 25. And we see here a very practical case where we can use the approximations which we are taught in mathematics. 1 minus e to the power x can be written as x. 1 plus e to the power x, sorry. So in this case, 1 minus e to the power minus x, if you expand this, it will be 1, and there's minus 1 by 25 in other terms. So this will be 1 by 25, which is basically 4%. So the answer is 4. Right, because we are asked to express in the nearest integer percentage. Finally, let's move on to the last question of this paper, the 20th question. Circular disc of mass 50 kg is rotating with an angular velocity. Two uniform discs are placed symmetrically on the disc, and the friction is large enough so that the rings are at rest relative to the disc. New angular velocity. So if we consider the whole thing as a system, the friction or the angular friction will just be an internal force and it won't contribute, and we can just equate the angular momentum. So initially it will be 50 into 4 by 10 whole squared into 1 by 2. This is mr square by 2, the initial moment of inertia, into omega 10. That will be, omega, which is 10. That will be final omega multiplied by the final moment of inertia. What will the final moment of inertia be? It will be this term, 50 into 4 by 10 whole square into 1 by 2, plus 2 times the moment of inertia of each disk. And here is the important part. We are calculating the moment of inertia about this axis going inside and outside the plane of this disk. Right. So we are not calculating it about the center, we are calculating about the edge. So if here it's mr square by 2, mr square, it's not a disk, it's a ring. So if about this axis it's mr square, then this is mr square plus mr square, or 2mr square. So this 2 is because there are 2 rings. This 2 is because it's about the edge, not about the center, into mr square. So 6.25 into 1 by 5 whole square. Right. So this will give us 50 by 2 is 25. 25 by 100 will be 1 by 4. So this will give us 40 is equal to omega times 4 plus, what is this term? 6.25 into 4 is 25 by 25 is 1, which gives us omega is equal to 8, which is the answer. Okay. So this completes the solutions for paper 1 of the 2013 JEE Advanced Physics paper. Thank you.